and H plus terms interchangeably, okay? They essentially mean the same thing. That might sound weird, feel weird for you to say that, but also get comfortable with that idea. Okay. So we just looked at, an example of an acid in aqueous solution, and we're going to look at another example of a different acid when we say we dissolve it in water, or again, water is an aqueous solution. So what happens when we put an acid in water? I'm just going to look at another example. Here, our acid is HNO3. We call this nitric acid. Okay, you might recognize NO3 minus is a polyatomic ion from your polyatomic chart. And here we've reacted that polyatomic ion with a hydrogen ion, and we have the acid, nitric acid. And when it reacts with water, if HNO3 is the acid, it is going to give away or donate this acidic hydrogen right here. So it's going to leave HNO3, it's going to join up with the only other thing present, which is water. So when this hydrogen leaves HNO3, what's left over is NO3 minus. And again, we've made now what we know as the hydronium ion, H3O+. Okay? So water is picking up, it's receiving the acidic hydrogen ion, the acidic proton that the acid gives away. Okay? And then the H+, this is just explaining what we just said. The H+ attaches to the lone pair on water, and it makes the hydronium ion. Okay? Now, where is the lone pair on water? If we say the lone pair on water, where is the lone pair on water? Let's draw a water molecule. We know a water molecule looks like this, and it's this oxygen right here that, guess what, has two lone pairs. Okay? So when we give away this hydrogen ion over here, it is attaching to one of these two lone pairs. And we'll actually go in depth about that a little more later on. But that's what it's binding to on water, because we form a chemical bond there. If you go back up to this slide, and you look right here, we have formed a bond right here. And that bond is made up, we know every chemical bond is made up of 2 electrons. Okay? And notice, when we form the hydronium ion, oxygen just has one lone pair left on it, because the other lone pair is now involved in this chemical bond that picked up the acidic hydrogen from the acid. Okay? So that's what we mean when we say the hydrogen ion, the proton attaches to the lone pair on water. Sometimes you can write it without putting water in place. You can just write how the acid dissociates into NO3 minus and H+, okay? Because remember, this H+, it can kind of come on and off of a water molecule. On and off to create H3O+. But either way, this top number 1 reaction or number 2, they both mean the same thing. Okay? We've already said this, so just get comfortable with that fact. They mean the same thing. Okay, organic acids. What is an organic acid? Because this statement says organic acids do the same thing. What do we mean? They do what? Well, they donate a hydrogen ion. If it's an acid, it's going to donate a hydrogen ion to something or someone. How are organic acids different from the acids we've talked about so far? Well, I don't have a lot of space, so I'll write it down here. HCl, that's one acid we looked at. HNO3, these are ionic compounds. Okay, there's no carbons in them. You have your cation and you have your anion, same thing, cation here, anion here. Now, organic acids, they can be made up of a cation and an anion, but oftentimes they have a lot of carbon and oxygen, okay? So organic acids, the reason we call them organic is they have carbon. Oops. They have carbon somewhere in the molecule. Okay, that's what makes them organic. So if you notice, we have 2 carbon atoms in this molecule. This is actually acetic acid. I'm going to give myself some room here to write. So this is acetic acid. Does that sound familiar? In your titration experiment or assignment that you did yesterday, you watched the video on titration. We would have used acetic acid. If we had done it in the lab, we would have used acetic acid with sodium hydroxide. And this is what acetic acid looks like. You have 2 carbons. This first carbon has 3 hydrogens on it. You've also got 2 oxygens in the molecule, and then you've got this last remaining hydrogen, which is a different color, that's important, attached to this oxygen, okay? This hydrogen right here attached to the oxygen, this is our acidic hydrogen. This is the one that's going to be donated by the acid. And we're donating, it looks like, to water, okay? And we're forming the hydronium ion, H3O+. And then what's left over from the acid is, you might recognize this is acetate. It's an acetate ion. This is on your polyatomic chart, okay? So just to show you, organic acids do the same thing. They donate a hydrogen ion to something else. Another thing to mention about acids, though, is that they can sometimes donate multiple protons or hydrogen ions. So it says many polyatomic ions can exist as acids, several can donate multiple protons. So let's look at some examples of that. Well, one we've already looked at, HCl. This one does not have multiple hydrogens. It only has 1 hydrogen to donate. Additionally, we looked at nitric acid. Here's the actual Lewis structure for nitric acid. And there is our acidic hydrogen ion, or hydrogen. Because they only have 1 hydrogen in the whole molecule, we call these monoprotic acids. Mono meaning 1, protic meaning an H+, okay? So both hydrochloric acid and nitric acid are monoprotic, but we have several others. Here's 2 examples of what we call polyprotic. So these over here are polyprotic acids. So hydrochloric acid, nitric acid, monoprotic. These over here are poly meaning many or more than 1. Okay, so sulfuric acid. The 2 hydrogens in red, these are acidic, meaning they can be donated. And so we call sulfuric because it has 2 acidic hydrogens, a diprotic, di meaning 2, again, protic meaning H+, acidic hydrogens. Phosphoric acid, so you have the phosphate, this is PO4 3-. But when you add all these acidic hydrogens onto these oxygens, we now have H3PO4, and that negative charge is balanced. So this is phosphoric acid. We call it a, I'm on the eraser. We call it a triprotic acid, tri meaning 3 acidic hydrogens, okay? So these are polyprotic acids, sulfuric and phosphoric acid. You should also have recognized sulfate, okay? It's the sulfate ion, and we've put 2 acidic hydrogens on it to get the acid form, okay? Now, they won't give away, so let me make a statement real quick. Polyprotic acids they won't give away all their acidic hydrogens at one time. It's a step-by-step process, okay? They give them away one at a time. So it occurs in multiple steps, but they can give away multiple hydrogens.